Hello, this is Stephanie Washer, and I'm going to talk about IP and ICMP, Internet Protocol and Internet Control Message Protocol, ICMP. And they both reside at layer 3. So I'm going to go through these two real quick, and then we'll talk about probably IP we talk about consistently throughout this course. And it's at the network layer. It's the IP addressing portion. That's what IP is, Internet Protocol. And it's source and destination IP addresses that are put on in the header in that part of the layers. And it also enables the TCP/IP to work together. So the network layer, we've got the packets. Let me see if they... So back in this, I think I'm getting there. Oh geez, it's even back further. Here we go. So back in this section, we've got the network layer where we've got the header that we add on after the transport layer has put the protocol information on there. So this header is the source and destination IP address information. So that's what and it's considered a packet at this point. In layer 3, it's considered a packet. Sorry for your eyes. I'm going to skip over back to Internet Protocol. And IP again is connectionless, and so it needs TCP/IP to work together. So here's the IP packet, and this one happens to be IPv4. And we get the version in the corner. We've got we've got identification flags, we've got protocol, the header checksum, source IP, destination IP, options padding, and then we've got data. And don't forget that we have a TCP segment or UDP datagram depending on the information. And then the different fields, we have all of the information about the different fields. So the version is just going to identify whether it's IPv4 or IPv6. And then the header length is just going to be, it's just going to indicate that header length in bytes, 20 to 60 in 4-byte increments. There's differentiated services. It just tells the router the level of precedence. So whether, on what service it is and if there's a priority handling, if it needs to do that. Total length, identification, identifies the message to which a packet belongs. Flags, frame offset, time to live. So time to live depends on, it's like a unit of time, but really it represents the maximum number of hops that it has remaining. And then we got protocol. So it might be TCP, UDP, or ICMP, header checksums. And then we've got our source IP and destination IP address, along with options, padding, and data. And all that in there. It's a lot. There's a lot in each of the headers. But you'll notice that they're very similar. So, and we also have kind of been looking at the IP header here. We can see the different, how it's set up, and the flags, and the time to live, and the protocol, so we can see all of that source and destination IP address. Most of the time when I'm looking at these, the main thing I'm looking for is the source and destination IP address. Because what they might ask you in some of these questions is, what kind of header is it? It might ask you what layer this header is at, and since we see IPv4 information, we can say that it's a packet. It's a layer 3 packet. And then there's an explanation of all of the headers, which I just went through. I'm not going to go through that again. IPv6 packet, so we can see that it's a little bit different. We got more info, or more room for the source and destination IP, but we have kind of less information in here. So the packet is a little bit more efficient. So this is IPv6 packet. So we'll look at the IPv6 just real quick. We've got the version, we've got the traffic class, that's the priority, just like the differentiated in IPv4. The flow or sequence of packets, the payload length, the size of the packet or payload, the next header, the hop limit, source address, and destination. It needs 128 bits for both because IPv6 addresses are 128 bits long. So you need that much for both. And remember, the source and destination for IPv4 is only 32 bits. So we do have to, and then the data, that length is a little bit, is variable, so it just depends. And then here's the IPv6 header. Look, it's just, you can see that it is definitely a little bit different. It's a little bit lighter, but you can definitely tell the difference in the IP address, right? So we can tell that this for sure is version 6, even though it says IP protocol version 6 right there. And then we'll go on to ICMP, or Internet Control Message Protocol, again, layer 3. So IP helps direct the data towards correct destination. ICMP is a protocol that reports on the success or failure of data delivery. One of the ICMP messages that we use a lot, and I use, is ping, to detect if you can get to another computer or not. It doesn't correct errors, it just detects, and it just detects them. So instead, IP announces any critical information for troubleshooting. So IP messages are automatically generated by network devices like routers, and then utilities such as ping, which I just mentioned, ping. I use that a lot. So an ICMP header is inserted after the ICMP message IP header. So there's an IP header, and then there's the ICMP packet header that has the type, the code, the checksum, and then depending on what you're doing, the contents may vary with the optional field of data. So we've got the type is just what type of message. So like when you ping something, destination host unreachable could be one of those messages. And then let me put in, so let's do images. And so it could be where we have a good ping, where we're getting full information. It could be destination host unreachable. Let's see, I don't think there is a one that has destination host unreachable in here, but it will say reply from and then destination host unreachable. Or request timeout is another reply, not a reply, but another message that you can get. Yeah, these are all good ones. So we don't see any destination host unreachable. Okay. And then you've got your checksum and then the rest of the header. There's only a few in there. So IPv6 relies on ICMP v6, and that's the kind of the thing that happens is if it's IPv4, it'll have a v4 behind things. So IPv6 relies on ICMP v6 message protocol, and it will do different functions from ICMP version 4 and ARP for IPv4 networks. So there are different purposes for ICMP v4 and ICMP v6. All right, so that is everything for ICMP and IP for this section. And then the last video of section 4.1 will be over ARP, Address Resolution Protocol for IPv4, and NDP and Ethernet. So